Hey kids, we're back. And so with my class that was here, we found it useful to go back over the exact same example and redo it. And after you've struggled through that first video, maybe we can make some more headway in what actually is going on here. So you can sit back and watch if you want. You don't have to write anything down, but let's go through the same concepts. So two triangles are similar. That's a new word, okay? Similar. And the sign for that is that neat little sign there. So what you do is you say a triangle A is similar to triangle B. That's the symbol. What does similar mean? It means same shape, but different size. So one can be larger than the other, but they're going to have the same shape. Now, if they're going to have the same shape, guess what they got to have? They got to have equal interior angles. So corresponding interior angles have got to equal. So all of the inside angles have to match up to an angle of the other triangle. That's what's going to give them the same shape. But they're going to have different sizes, like the side lengths are going to be different. And that means that you're going to have corresponding side length ratios are equal. So this is going to lead to fractions that are going to be equal to each other. This is going to lead to angles that are going to be equal to each other. When naming similar triangles, the letters representing the equal angles must be written in the same order. So if I'm going to tell you that a triangle, let's call it DEF, is similar to triangle GHK, if I'm going to tell you that, and I tell you that they're similar, well, that means that angle D must equal angle G because they're in the same spot. It means that angle E must equal angle H because it's in the middle spot for both. And angle F must equal angle K because it's in the last spot. And it has to. If you're going to name them in this order, then that means that these corresponding angles must equal each other. There's no way around it. Let's look at the first example. So the first example is giving us some really important information. This is huge information. They're telling you that the triangles are similar. As soon as they tell you that, I'm going to tell you, so from this information, we know that angle A must equal angle D. We know that angle B must equal angle, why don't I have an equal sign there? I know that angle B must equal angle E, and I know that angle C must equal angle F because they're in the corresponding orders of each other. So as soon as they name them in that order, as soon as they tell me that they are similar, that means that they're the same shape. To be the same shape, these angles have to be equal, which means that angle A must equal angle D, so that must be 28 degrees. Angle B is 121, so this must be 121 degrees. And angle C I don't know, but angle F I do know, and that must be 31 degrees. And that's the way this works. As soon as you tell me they're similar, I know about their angles. I also know something else. I know that their side lengths are going to be, the side length ratios are going to be equal. That doesn't mean that the side lengths are equal, but whatever the ratio is between the side lengths, they have to be equal. So I can do the same thing. I can use what they've told me, and I can say that AB divided by DE must equal BC divided by EF must equal AC divided by DF. Now notice how I did that. I did that by looking at this. AB over DE, BC over EF, and AC over DF. And if we look at the triangles, you'll see I did AB, here's AB, over top of its corresponding side, which was DE. And then I did BC, which was here, over top of its corresponding side, which was EF. And then I did AC, which was here, over top of its corresponding side. So all of the sides from one triangle have to be on the top, and all the sides of the other triangle have to be on the bottom. Now we should know that I didn't have to go from this triangle to this triangle. I could have gone from this triangle to this triangle. So I could have simply said, or I could have said DE, the first two here, over the first two here, AB, would equal EF here over BC here equals DF here over top of AC here. And this is the exact same information. The only difference is I'm going from the smaller triangle over top of the larger triangle in its side length ratios. So we either work with this or we work with this. But as soon as someone tells you that two triangles are similar, you know that their angles, their corresponding angles must equal, and their side length ratios equal. How can we use this? Well, if we take the first one that I worked with, which was AB over DE equals BC over EF equals AC over DF, and we put in what we know, AB is 12.1, DE is unknown, BC is unknown, but EF is 8.8. AC is known, 20.1, and DF is known, 16.1. So I now have some information here that I can work with. If I want to determine DE, I have enough information. If I want to determine BC, I have enough information. Notice that there's three things being equal. I can cover up one and the other two still stay equal. So the game is going to be to pick which one to cover up and which one to use. So the first game is I'm going to find BC. So for BC, I'm going to say BC over 8.8 equals 20.1 over 16.1. What's the 8.8 doing to the BC? Division. What's the opposite of division? Multiplication. If I multiply this side by BC by 8.8, I get BC by itself, 20.1 times 8.8 over 16.1. Use your calculator. 20.1 times 8.8 equals, divided by 16.1, 20.1 times 8.8 equals, divided by 16.1, I get approximately 11.0. And so that was for BC. If I want to determine DE, I'll use 12.1 over top of DE, and that'll equal 20.1 over 16.1. Notice I'm not going to try to use those two. That would give me two unknowns, and that's no good. I want to use the one that has both the answers in the top and the bottom. This is a little bit tricky. There's a couple of different ways to do this. I believe the last time I did it by cross-multiplying both sides, and I alluded to the fact that we could flip both sides. So what I want you to notice is that I can easily do this. I can flip one side of the fraction as long as I flip the other side. And as long as I flip both sides, everything stays equal. So what's the 12.1 doing to the DE? Division. So the opposite of division by 12.1 is multiplication by 12.1. So that's going to get rid of it on the left-hand side. And we're going to work this out. 16.1 times 12.1 divided by 20.1, and we get 9.7 approximately. And that is how we would do a question like this. Straightforward. So, hope that helps, and come on back for example 2.